Alright, so let's continue. This is lesson number 2, Unit 11. And we had just talked about hydrocarbons, and we said that hydrocarbons can be broken down into saturated and unsaturated. They can also be broken down into two other categories, which are called open-chained or aliphatic, or closed-chained or aromatic. Now, on the Regents exam now, they don't really worry about the closed chain, so I'm not really going to worry too much about that either. But let's go through the different open chain or aliphatic. And what that means is open chain means that they're not connected in a circle or in a chain, and I'll show you the ones at the bottom, and you'll see the difference. To get the molecular formula, all you do is count up the number of carbons. 1, 2, 3, 4, 5, 6. It's 6 carbons. And if you count them, it's going to be 12. It looks like 14 hydrogens. That would be the molecular formula. The condensed formula would be just split it where in between each of the carbons, right? And then count them up. I have a carbon and 3 H's. I have another carbon and 2 H's. Hopefully I have enough room. Carbon and another 2 H's. Carbon, 2 more H's. Carbon, 2 more H's. And carbon with 3 H's. And that would be the condensed formula for the first one. Okay, next one. This is even easier. It's a smaller compound, so it should be easier. We have 5 carbons, looks like, and 4 carbons, sorry. 4 carbons, and looks like 10 hydrogens. The condensed would be CH3, CH2, CH2, CH3. Okay. These are both saturated hydrocarbons, which means they are both alkanes. We're going to get into that next. Now, if you look at the bottom one, that looks similar, but it is one big difference, and it's a big difference. Notice that it has a double bond. So right away, because it has a double bond, we know it is unsaturated, and we know it's an alkene, and we'll worry more about that later. So let's go through the molecular formula. We have, looks like 1, 2, 3, 4. It has 6 carbons, and if you count up the H's, it has 3, 4, 5, 6, 7, 8, 9, 10, 11? No. 5, 6, 7, 8, 9, 10. It has 12. C6H12. So notice there's twice as many H's as there are carbons. One of the things you should notice is that, remember we said that every carbon, this is an important fact, has to have 4 bonds around it. So if you look at this carbon here, it does indeed have 4 bonds. It has 1, 2, 3, 4. Remember, the bonds, the dashes, are for both atoms. So this carbon has 1, 2, 3, 4 bonds, and that's how you would do it. So let's go back and do the condensed formula. It is going to be CH3, CH2. Now this carbon has only 1 H, and this carbon has 1 H, and then you have CH2, CH3. Now if you take a look at this last one here, this is what we call aromatic or closed chains. This happens to be something what you don't need to really worry about. The molecular formula, of course, is easy to figure out. Get it? You count up the carbons, and it looks like 1, 2, 3, 4. It has 6 carbons, so it would be C6. And each carbon looks like it has 2, so it would be C6H12. And that would be the molecular formula. And that's kind of it for this particular lesson. We are pretty much done. I'll hold off for the rest.